Hello again, everyone. In this video, we will explain the questions with highest marks. I mean the graph, domain, asymptotes, how to solve logarithm equation, how to graph sine and cosine functions, and all this only. So we need to sketch this graph. Then we find the domain and range. Okay, the parent function of the log, which is log x. When we sketch this, we avoid this origin and take one step to the right at 1, then sketch have the graph here increasing on x and y, and the second half is going down here. It doesn't touch the y-axis, but it keeps going down with the y values to negative infinity. Okay, if this is the parent function, how to graph this function? The domain for this is all positive values of x, as you see, because it goes here and goes left slightly here. So the domain is all x greater than 0, because it doesn't have here, it even doesn't meet with the 0 at the y-axis. Then we have the range. The range on the y-axis, it keeps going up and down. So all the reals are on the range. So how to do the same for this example? This example, we said we can shift the parent function 4 units, but you know that x is the opposite. So 4 units left. So instead of using this origin, we need to move 4 units left here. Then we have our new asymptotes as the y-axis here. And before we start, it's wrong to start here. We take one step as we did in the parent function at -3. We have the graph sketch here, and the second is here. And the domain is all x greater than -4. As you see, we are greater than -4, and the range all real. That's it for this example. It's easy, right? Here, let's do different example first, then we go back to this log base 3, for example, 5x or 5 plus log base 3 x plus 2, and this is equals, for example, 4. For example, 4. Here you have the properties of logs. If you have addition, you can make them in one log. Okay, it's how to okay. The problem that you don't have log here and you have two logs, you can combine the two logs by addition property. Here goes back again to multiplication to the same base, and this is 5 multiplied by x plus 2, because we can go back with addition to multiplication. One log 5 multiply x plus 2 equals 4, but we still have a problem in the right side because we don't have log. We can add log 3 base 3. If this is 8, we can add log 8 base 8. We should have same base, so here it's 3 of 3, and this is 3. Okay, so the first step, we combined the addition by multiplication, and the second step, we added log 3 base 3 in the right side. Okay, now we have log base 3 5x plus 10, and here we have log 3, and this 3 is raised to the power 4. How to know this? Because we said if we have a power in the last video, you can use this power as a coefficient to the log, as also vice versa, you can send it back to the power. So this 4 can come here as a power for the 3. Now the easy part, you can cancel log 3 and 5x plus 10, will be equal to the answer of 3 power 4, which is 81. How to solve this? 5x equals 81 minus 10, which is 71. Divide by 5, 71 over 5, and write your answer in simplest form. To do the same with this example, look at the property here. Addition comes from subtraction. So this is log 4 negative x over 2, and the base is 4. Here we have log 4 and 12. This is easier because you can cancel this now, and negative x over 2 equals 12. So negative x equals negative 24, and x equals negative 24. When you substitute by negative 24 here, it's negative 24, it's positive 24, so it's okay, and the answer is accepted. Okay, if it's negative, you will reject the answer. For more examples about this, watch lesson 7. Okay, how to solve this? If this is directly, we use y equal kx. So we write 15 equals k multiplied by 5. So it's 5k. Now we divide by 5, so k equals 3. Then we go back to this and rewrite y equals 3k. When he asked about 3, y equals 3 sorry, this is 3x, because k equals 3. This 3 is k multiplied by x. In our case, it's 3 also. We multiply them to get the answer, if this is direct. If this is inverse, as you see here, you use a different formula, which is y equal k over x. Replace 15 and 5. So this is 15 when x equals 5. So how to find k? Multiply, this is 75. Now you have k. Redo the same step. Y equals 75 over x. Substitute by 3. Y equals 75 to see the corresponding value for y when x equals 3, which is 25. Okay, there are two different examples. Here we have the asymptotes and the vertical horizontal asymptotes. Can you see that this is 3? It means we have to move left 3 units, and we move down -2. So move your origin, this origin, to -3 and -2, and regraph this here as an asymptote, horizontal and vertical asymptotes. Then we sketch. If it's positive, sketch here, and it's negative, sketch in the second and fourth. How to know it's positive or negative? This is positive. If it's negative, it will be written negative here. Now the question that you all like. If you, sorry about this, I will write in the exam that we need a vertical asymptote. The vertical asymptote is x equal -3, because you move the vertical asymptote to -3, so it's clear. And the horizontal asymptote, y equals -2. If you were asked about the domain, all except -3, because the domain in all x except this asymptote, and the range is y all except -2, except this -2. So yes, we take this for the domain and this for the range. Here, vertical asymptote, horizontal asymptote, and domain. Horizontal asymptote is easy. If the power up is greater than the power down, we say none. If it's in, like our case here, the denominator is with bigger power, we say the horizontal asymptote y equal to 0. We have an asymptote, which is y equals 0. This is the first one. The second one, to find the vertical asymptote and the domain, you need to factorize. How to factorize this? And you have a negative sign. You should take this negative sign out. If you can take x as a common factor, you need to take x as a common factor before you factorize. Now the easy part. This is negative, and the two brackets are x plus 2 and x plus 3. X and x plus 2 with x plus 3. Now to find the domain, this gives 0, -2, -3. So the domain is all reals except 0, -2, -3, because we cannot substitute by value to give 0. It's unaccepted to divide by 0. So that's why we exclude the 3 values. Then you get the vertical asymptote. X equals, don't write 0, -2, and -3, because you can cancel this with this out to cross this, and this with this to cross this. So only x equals 0 is the vertical asymptote. Okay. Now how to graph the sine and cosine functions. We have constants. Okay, let's go to a different example and come back to this. Here we go. Okay, this color for the example, and the red color for the constants, the steps you use in each example. Okay, again, the red are constants. Use it every time with this example. This color, I cannot recognize the name of this color actually. Is the answers. So the amplitude, you find amplitude each time for this example. The amplitude is 3. Okay, amplitude is 3. Then the period is 2 pi. That's why I wrote it in red, because it's constant, 2 pi for the sine and cosine, because the wave repeated after 2 pi. Divided by 4. This is not constant. This is from the example, which is pi over 2. Then critical points. It's pi over 2, the answer that you got from the period, divided by 4. Divided by 4 is constant. That's why I wrote it in red to get pi over 8, which is the steps, the distance between each 2 points on the graph. The force phase shift. This bracket, put it equal to 0. Then isolate theta. Theta is the angle, it's variable. We change the theta each time. So this is theta, like x for sides and a for angles. Okay, pi with positive sign, then divided by 4. The answer is your start. Sorry. The answer is your start. So we start by pi over 4 as we started here. Okay. If we have a vertical shift, it will be written here 2 units up or 2 units down is okay. If you want to graph without the vertical shift, to know the graph without the vertical shift, okay, yeah, forget about this and try to graph without vertical shift. This is pi over 4, and to find the next steps, you have to add pi over 8. It will give you 3 pi over 8, pi over 2, 5 pi over 8, 3 pi over 4, and so on. To graph the sine, you start from your phase shift, skip this and take this, skip this and take this, and so on. What about this one? Your graph is positive 3, so you put this at the maximum amplitude, which is 3. Then this goes down to the negative 3, and this up, and this down, and so on. And you can graph like this. Okay. We did the same with the vertical shift, but it's okay. If this graph was cosine, let's change everything, because in cosine we don't start with the phase shift on the x-axis, we start with the phase shift on the maximum or the minimum. Okay, if this was cosine, like I have graphed in the yellow, if this is cosine, you don't circle this and start, no, you circle the second one and skip this. So skip first and take the second, skip, take this, skip this, take this, and so on. So the graph should pass by this point. How about the first point? We start from up the maximum positive 3. If it's negative 3, start from the negative 3. Then go to your graph. This would be down, and so on. So this is the difference between the sine and cosine graphs. Can you screenshot for this or write it in a different paper and try this? The red parts, try this here. Amplitude is 1, period is 2 pi, divided by this, which is 2. It's pi. Then divide by 4, because we always divide by the period by 4. It's pi over 4. So this is your steps. Isolate this. 2 theta minus pi over 3 equals 0. So 2 theta equals pi over 3, and theta equals pi over 6, because we divide by 2, and by 3 it means we divide by 6. So this is your start. Start at pi over 6 and keep adding pi over 4, pi over 4, pi over 4 by the calculate, pi over 4. If it's sine, we take this and skip, take and skip, take and skip, take and this. This is with the maximum, minimum, and this is your graph. Sorry, so easy. Okay, you can do the cosine and check your answer for this from the model answer 3. We have some notes. Actually, there are 2 notes. Sine 50, for example, equal cosine what? It's cosine 40. Sine 30 equals cosine 60. Cosine 80 equals sine 10. Why? Because 50 and 40 add up to 90. 30 and 60 add up to 90. 80 and 10 add up to 90. This is the first one. The second one, which is called the reference angle, sine, for example, 210. Sine 210, you look at this. 210 is the third quadrant, and the rule for the third quadrant is theta minus 180. So we write 210 minus 180, which is 30. So the answer should be sine 30, equal to sine 30. Okay, but when you look at the third quadrant, you see that tan is only the positive function ratio, so this should be negative sign. Okay, you don't understand, I know, but you need the different one. For example, cosine 315, tan 315. Cosine 315. This cosine in the fourth quadrant is positive, because the fourth quadrant we have C positive, so the answer would be also cosine, not negative cosine. What about 315? The rule for the fourth quadrant is 360 minus theta. So 360 minus 315 is 45. So your answer is 45. But for tan 315 in the fourth quadrant, the tan is not positive, so the answer is negative tan. 315, the fourth quadrant is the reference angle is 45, because we subtract 360 minus theta. So the answer for tan is negative tan 45. Cosine is cosine 45. Can you try this? Sine 225. This is the third, 225 minus theta, and the sign is negative in the third, so it's negative sine. 225 minus 180, sorry, minus 180, so the answer is 45. But sine 135, 135 in the second sign is positive, so it's sine 135. The rule is 180 minus 135 here, so it's sine 45. Thank you for watching this long video, and I hope you good luck in your all exams, and see you inshallah next year, next days, and I hope you all enjoy your next days. Thank you. Goodbye.